Alright, we're back here on the bench tonight with the Luxman RV-371 processor board. In the last video I showed that I acquired the service manual from a nice viewer that sent it in. Thank you very much. And like I said, I would pass it along if viewers have emailed in to me that they're looking for it also, and I have passed it along to one person already. So like I said, you know, if you're looking for it, contact me. So we're looking into the rest of the issues with this board, which is the left or right channel is not appearing in certain surround modes, so we think we still have a few issues with connections. I believe all the capacitors are fine, they're brand new. So the rest of the issues I believe now, I think maybe passive components mounted on the board, minus the electrolytics. So, or bad connections on the traces themselves. So we're going to be looking into this via that I had found that was very questionable, and it's going to definitely need to be repaired. So let's get to the microscope and let's double check that out tonight. Alright, let's fire up the solder iron because we're going to need that nice and hot. Let's see. The issue is with C907. We're going to have to pull that cap off and check that via underneath there. It looks like I may have already known about this issue, but not 100%. I think I've noticed that the trace coating had already peeled off, but I don't actually know if I ohmed it out or not. So we're going to pull this cap up. So I'm going to put some flux on this connection. Get this centered back up here. And we're going to try and wick a lot of this solder off of here. If you plan on reusing the cap, which I do plan on doing, you don't want to use hot tweezers, because the hot tweezers will destroy a capacitor. They will overheat it and cause it to pop, and it's not a good thing. So if you plan on reusing the surface mount electrolytic, I suggest you do it the way I'm about to show you. It gives it a little, sees a little less heat this way. Alright, so basically I just put some flux on there to reflow this solder a little bit better, and I'm going to put some solder wick, and what I use is No Clean SD by Chemtronics. It looks like size number 3 and 60-3-5. It's right here. I don't know if that's going to come out in the camera or not, but so let's get rid of this cap. Now you want to stay away from the plastic as much as you can on underneath this cap, because it actually will melt. Alright, so we think we've got a lot of that solder away. Alright, so it appears that looks like we've got most of the solder off. Now it's just going to be a question of trying to rock this thing off the pad slightly while we're heating it, because there's still just a bit of solder under there that we cannot get all of the rest of it. So we're going to get a pair of tweezers.
This is.
Sorry about that. So we're going to heat this one side, just tip it up a little bit, and let it cool a little bit. And we're just basically going to rock this part off the pads. It looks like this one side is maybe, this pad might be a little loose or corroded, as we know. There we go. Yeah, that one pad here is a little finicky. It looks like it tried to come up because of all this corrosion that's underneath it. It's still good. We'll try and just flatten this out a bit, because we know this veer has an issue, but we want to keep as much as we can without ruining it. We'll try and clean that hole out. Alright, before we go any further, let's check the connection. Let's go to the test equipment cam here. I'm going to put this on ohms in continuity. Alright, let's see if we can get microscope test equipment. Alright, so now we're going to test this pad to the minus 15 volt rail. Alright. No connection. So if I take this now and I stick my other probe inside here, let's see if we get a connection. We get a connection here. But nothing inside down on the actual solder that's flowed through there. So around this, right underneath this, where it connects to the via, is broken away. So we're going to actually try and clean this hole through and maybe put a wire through there. I mean, obviously this pad has seen some corrosion, and there's not really too much we can do. As long as we don't destroy it any worse than it is, we will be able to reuse this. So let's go back to the microscope cam. All right. Good. All right. It's going to be a little tough cleaning this out here. I'm going to stick my tweezer in there. Just kind of rotate it a bit and see if I can get any kind of... Alright, let's try to work on the back side. Alright, let's refocus. Now I believe this is the via right here. It seems to be in the general area. Let's try and see if we can confirm that. It appears so. So what I'm going to do is I'm going to throw some flux on here and heat this up. Maybe throw a little bit of solder on there as well. Try and flow it a bit. I want to keep heating it because I'm going to try and get this corrosion out of here with a solder pump. We'll see if we can pull that all out. Yeah, looks like we may have gotten a little bit of it out of there. Throw some more flux at it. Now what I'm going to do is I'm going to take some 30 gauge wire and I'm going to see if I can pierce through this while heating it. Okay. You want to use a pair of tweezers for this because it gets really hot. Now I'll throw some more flux in the area. This seems like it might be pretty well burnt off. Let's see if we can push this through. Yep, went right through. Good. So now on the flip side, let's hope we came out at the right spot. Let's refocus here. And looks like we did. So now what we're going to do, let's see if we can get in a little closer on this. Okay. I'm going to try and just scrape a little bit of this corrosion off of this copper lead here, going over to the pad. Because when copper is tarnished, it's a real bear to solder to. It looks like it's well clean now. So basically what I'm going to do is take some alcohol, wet the area a bit. And we're just going to cotton swab some of this garbage that we picked up. Well, we don't want to do that. That's a big no-no right there. Whoa! Yeah. I got some foam cotton swabs coming soon. This is not the right way to do this, but if you ever do that, there we go. Come on, get off of me. Yeah, this pad definitely already had some issues, so we're not going to try and aggravate it any more than it is. You can already tell the left side here is already all corroded away and it's just shriveled into this little bit of a pad. And down in here you can kind of see that this has been etched away a bit. So now we're going to take some flux. And we're going to try and fold this over. This in turn will kind of help keep the pad down. But I'm not going to keep the wire all the way through the pad here because it's going to make the capacitor not sit correctly. So we're going to end up cutting this after I solder it. Actually, you know something? I should probably cut it now because once I solder it, it's just going to flow across it. So we're going to cut this right at the pad junction. I'm going to lay this down. And we're going to hit it with a little bit of solder. And that's really all you need. Because once you flow the capacitor back on there, it's going to wick up some more solder. So, all right, let's put the capacitor back on now. First, let's clean up our area a little bit. That's probably as good as it's going to get. I'm going to back up this microscope a bit. Alright, so let's get the component. Actually, before we lay the component down, let's do another check on continuity. I mean, I know it's going to be connected, but for demonstration purposes, we should probably do this. So we got here to the minus 15 volt rail, and we're good. So that is now a restored connection. So now we can definitely be assured to lay the part in and not have an issue. I'm going to actually clean some of this old crap flux off first. I really hate using cotton swabs. I got some foam ones coming, because as you saw, it just picks up on every corner, and it can really, it just sucks. So I ordered some nice foam covered cotton swabs. Should work out better. I mean, if you were really finicky, you could try to put some epoxy under this pad. I don't think it's necessary in this case. Oh, I almost forgot the most important thing. Now, since I don't have 3 hands, I'm going to put a dab of solder on my tip of my iron, and hopefully with the flux that I already have on this board, it should flow. Okay. So now we can go to the other side. That should do it. It's not the prettiest thing in the world, but it's electrically sound. Let's get the Q-tip back. Yeah, not too bad. Alright, so that definitely has corrected the issue with the capacitor connection. Let's go to the desktop here. Oh, wrong one. No, what's the right one? Let's check this out. So we have restored this connection here, this minus 15 volts, to the actual minus 15 volt connector. So I'm hoping that this circuit is going to work correctly now. I'm not exactly 100% sure what it does, but it looks like it's either stiffening up or filtering the minus and positive 15 volt rail in relation to this ground. So I'm not entirely bought that this is going to fix the left channel issue, but hey, who knows? Stranger things have happened. So I'm going to have to put this back on the receiver and give it a test, and I will make another video when that happens, which will probably be very soon. So stay tuned for that. Alright guys, we'll see you in the next video.